Okay, so guys, we made it. This is the very last video of the year. Anyway, this is kind of exciting. We're almost done. Your big project's coming up. So this is lesson 9.6, testing two proportions. We're actually not going to use the graphing calculator for this. I want you to actually use the formulas, okay? So keep in mind that when we use these formulas, this p hat minus p1, when this p1 minus p2, that's 0. That's the same like when we did with the very beginning when we used the test with mu1 minus mu2. You can cross that out. You will need the rest of these formulas. So you might want to write these down or at least take a picture of them so you have them. So this test isn't really that difficult. It's just like the other tests that we ran. So example 1, it says, a study is conducted to determine if the percent of women who receive financial aid in undergraduate school is different from the percent of men who receive financial aid in undergraduate school. A random sample of undergraduates reveals that at alpha equals 0.01, is there significant evidence to reject the null hypothesis? So we want to say that there's difference, not necessarily that one's bigger than the other. So we set up our hypotheses. Maybe? Okay. All right, we're going to find P1 hat. Okay, so 180 over 300, that's the percentage of men. And that's 0.6, the percentage of women. Okay. Is 0.08, which was 200 over 250. So we want to say, is this really bigger than, or is there really a difference between the amount of, the percentage of men and the percentage of women that receive aid in school? So P flat, I don't know what to call it, all right, P bar, is the samples added together over the total, which is 0.691. So now, our H naught is that the P1 will be equal to P2. We don't want them equal to each other. And H naught is that, or H1 is that P1 is not equal to P2. Our critical value, looking on the chart, for alpha equals 0.01 for two-tail is 2.58. Our Z, all right, this is, so 0.6 minus 0.8 over the square root of P bar, 0.691 times Q bar, 0.309. These formulas are all on the other side. Times 1 over 300 plus 1 over 250. Okay, so huge formula. Be careful on the calculators. Okay, I end up with negative 5.054. Okay, so I can definitely reject, which means I can say there is a difference between the amount of aid that women receive and the amount of aid that men receive. Okay. So again, make sure that your conclusions are sound. All right, practice 1. This is a practice problem. You're going to test whether let's see, it's the nursing home study mentioned in the chapter. The researchers found that 12 out of 34 small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 large nursing homes had a vaccination rate of less than 80%. At alpha equals 0.05, test the claim that there is no difference in the proportions of the small and large nursing home with a residence of vaccination rate of less than 80%. Be very, very, very careful on this problem. 80% means absolutely nothing to the problem whatsoever. We want to say, is this proportion less than this proportion? Hang on, is there no difference? Hang on a second. Yeah, nope, so there is no, it's just equals and not equals to. There is no bigger than or less than. Okay? So be really careful with problems like this. You need to make sure you read them carefully and understand what they're asking for. Okay, so here's the solution. So we figured out our P hat 1 and our P hat 2 by dividing. Okay, and we got 0.35 and 0.71. Then we got our P bar and we got 0.5 and our Q bar, which is also 0.5. Okay, so the hypothesis is that they're not the same. H1, H naught is that they are the same. We compute the test value by plugging everything in. Okay, oh, and the critical value is positive and negative 1.96. Now we get negative 2.7, so we can definitely reject and say that there is a difference. So there's definitely a difference between the vaccination rates in the nursing homes. All right, see you tomorrow.